Hello. Hello, Mr. Mike.
Hello.
Hello.
Hi there. What's your name?
My name?
Sure. Yeah, what's your name?
My name is From the Front.
Nice to meet you.
Nice to meet you.
And see, we had somebody else there on the call for a minute. Where did she go?
I don't know.
Me? You mean me?
Yeah.
I am your teaching assistant this lesson.
Okay, sorry.
Okay, no problem.
Nice to meet you too.
Nice to meet you. Okay.
So we have Fat. Are we waiting on anybody else?
Sure.
No, you only have him during this demo.
Okay, just one student.
Yes.
Okay, cool. Hi, Fat. So, like I said, my name is Mike, and I'm going to be the teacher for this class. Okay. So this class is going to be a science class, and we'll be looking at many different topics relating to science. It will all be conducted in English. Okay. If you have any questions at any time, just feel free to just stop me and let me know if you have a question. Okay?
Okay. No.
All right, so let's go ahead and get started. Our topic for today is just going to be an introduction to science. Okay? We're going to be looking at what does science mean? What are some basic ideas that we need to understand when we're talking about science? And then we'll be looking at some examples of some basic areas of science. All right, so before we get started, Fat, could you tell me a little bit about yourself? How old are you? Go ahead.
My name is Fat, and I'm 13 years old. I'm studying at Northwestern Secondary School.
Okay. And is that in Hanoi?
Yes.
Okay. And what grade are you in school?
I'm 7th grade.
7th grade. Okay, good. Great. And do you like science? Is that your favorite subject?
No, it's not really my favorite subject.
Okay. What kinds of subjects do you like at school?
I like physical.
Like physical education?
Yes.
Like a gym class?
Yes.
Oh, yeah, that's fun. And are you a fan of math?
No. I don't like math so much.
Okay, no problem. The good thing about this class is we won't be talking too much about math, but science is closely related to it. Instead, we're going to be talking about some ideas about science mostly. Okay, great. So first of all, what is science? Can you explain to me what science is?
Science is science is the list of branch of science.
Now, don't worry about this. Don't worry about this. Can you just tell me, in your opinion, what is science? Or in your view, what is science?
Science is something that we to do that we to know what is we sometimes do the experiments.
Good.
To know what the problem is there.
Sure, yeah. Science is basically the study, it's a kind of study, right, about the world and everything in it. And you're right, we do some experiments to kind of find out more about the world and the things in it. Can you tell me some examples of branches of science? Do you see this word here? Hold on one second. Yeah, this word branches here.
Yes.
What do you think that means?
That mean I don't know about it. I don't know
No.
what branches.
No problem. Branches simply means different kinds of science, different types of science. Okay, you might have heard of many of them already, like the science of life is biology. Have you heard of biology before?
Yes.
Good. Have you studied any biology in school?
Yes.
Yeah, good, good. So biology is a kind of science, a branch of science that looks at life in all of its forms. And the kind of science that studies, let's say, chemicals, like
Chemistry.
chemistry. Yeah. So that's a branch of science. And there are many, many others. We'll look at some of them today. Can you think of any other branches of science?
Branch. In my school, sometimes we are studying about electricity.
Good. And do you know what kind of science that is, electricity is used in?
I'm not sure.
Starts with the PH. This one's physics. Have you heard of physics?
Physical education.
Not physical education. Physics is the study of basically like laws of energy and matter. It's like kind of like the study of electricity. Electricity is involved in it. And it's a lot of basically how we make things too. Like how do computers work, for example? That would be an aspect of physics. Good. Let's look at question number 2 here. Who is a scientist?
Scientists is who always do the experiments about something.
Yeah, good. People that do experiments to figure out something. What other kinds of things does a scientist do to or use to figure out new things, to learn new things?
They do experiment to learn the new things.
Yeah, good. They do experiments to learn new things. What kind of things do they use to do experiments?
They use their brain and
Good. They use their brain,
their eyes.
their eyes. Good. They observe, right? They see things and they try to understand what's happening based on what they see. Where is the place that a scientist does experiments?
They do at the lab.
Good, in a lab. Yeah. And in the lab, there are many tools that a scientist uses, right?
Yeah.
What kinds of tools does a scientist use?
I remember they have something to pour in.
Yep. Good. So like a little glass jar, right? We call that a beaker.
And they also have the glass. They to protect their eyes from the explosion. Maybe.
Yeah, good. So they have like safety goggles. Right? Very good. Okay, great. Excellent job. So really quickly, before we move forward, we're going to do a little activity. Fat, do you have a piece of paper with you?
I have.
Okay. And do you have a pencil?
I have.
Great.
Yes, I have.
I'm going to set a timer. Okay, I'm going to set a timer for 3 minutes. And what I want you to do in those 3 minutes is quickly, I just want you to write down a list of every word about science that you can think of. All right? It's a brainstorming activity. So what I don't want you to do is I don't want you to write a full sentence. All right? I just want words. Okay? As many words as you can think of in a list. Anything about science. But do you understand?
Yes.
Okay, perfect.
Wait till I'm going to get my paper and the pencil.
Sure, go ahead.
Okay.
Okay. So, yeah, you ready to go?
Yeah.
I'll start the timer. Go ahead and start writing. Okay, Fat, that was 3 minutes there. Let's see. Let me pull up a list here.
I only have 5 words.
Oh, really? Okay, well, let's hear them anyways. What are your words?
Experiment.
Good.
Safety goggles.
Good.
Jar.
Uh-huh.
Electricity.
Good.
Biology.
Biology. Okay, good. Okay, so let's look at these words. Where do experiments take place? What kind of room do scientists use to do experiments?
They do something to
What was that
find.
word that starts in an L, with an L? What room?
They do in a lab.
Good, a lab. Do you know what lab is short for?
No.
Lab is the short form of the word. There's a longer word that's laboratory. Laboratory. So that's what lab is short for. Safety goggles, we already know. The jar that scientists use is actually, there are many different names, but one of the most common ones is a beaker. A beaker is the basic jar that they use. Electricity, we know, the study of electricity belongs to physics, and that's the science of matter and energy and transformations. And also, kind of like another area of science, engineering. Have you ever heard of engineering?
Yes.
Yeah. So when you hear the word engineering, what do you think?
I think that it. I just heard of it, but I don't know what it's about.
Good. It's so engineering, people usually think it is for constructing things. And often it is. It's like a science-based field. And when we usually think of people that are engineers, we usually think of them as building things like roads or bridges or buildings, things like that. But engineers come in many different kinds, right? Many different types. There are engineers that's focused entirely on electricity. So they design basically whole electrical systems or circuits, things like that. There are also engineers that work with chemicals. So they create new materials just entirely out of chemicals. And then there are engineers that focus on things like software, right? So they only build things that exist in computers, right? So they using code, software code. So there's many different kinds of engineers, but they all are kind of focused on building things using science. Does that make sense? Do you understand that, Pat?
Okay, I understand.
Good. This is the correct way to spell laboratory, by the way. I had a mind blank and couldn't remember, but that's how we use it. Remember, that is the long form of just the word lab. Okay, good. Let's go ahead and move on to our next one. Okay, so just to kind of summarize, what does science mean? Put this back up. Science is a practical way of understanding the world. In science, we find out how things are made and how they behave. Okay, so again, we're looking at understanding the world, and we're finding out how things are made and how they behave or how they act. What are the discoveries and applications of science that you know? Can you think of some famous scientific discoveries?
Thomas Edison.
Good. What did he discover?
He discovered he discovered the
So he was famous for he didn't discover electricity because people had known about electricity for a little while, but he is famous because he is one of the first people to use electricity in machines, right? Like he invented the light bulb, right? That's the reason why our houses have light in them now, right? He also invented some things that we don't really use a whole lot nowadays, like the phonograph, which is like before there were MP3s and CDs, way before that, people had big discs, and they would play music from these big discs. And he invented something that could, play music like that. He invented a bunch of other things, but he's best known for using electricity and also in machines and also inventing the light bulb. Any other famous discoveries?
Isaac Newton.
Good. What did he discover?
I remember he discovered the gravity.
Good. He discovered gravity. That's physics right there. So Isaac Newton, he was a physicist, meaning he was a scientist who studied physics. That's what physics kind of is. It's a lot of math, but it's also studying like laws of nature, right? Things that happen in the world. Good. Any other discoveries that you know of?
No, I don't know any.
Yep, so there are many ones, right? There are tons and tons of famous scientists over the course of history. We'll talk about a few in this class. Before we move on, let's look at a few different branches of science. Okay, so there are different branches of science. This branch here studies living things.
And biology.
Good, this one's biology. Let's write that in there. Okay, good. So the study of living things is called biology. Very good. Any idea what this is? Matter, energy?
Physics.
Very good. This one's physics. The study of matter and reactions.
Chemistry.
Very good. That one's chemistry. The study of the soil and rocks. This one might be a little bit more difficult. Might not have heard of this one before. This one's called geology. This word geo right here means earth, like the planet Earth. And then geology is the study of the things in the actual planet Earth. So rocks and soil and things like that. Okay, good. I'm sure you've heard of these ones before. Have you heard of geology before?
No, I don't.
So geology is, they study many, many things in geology. My sister actually studies geology, and she focuses on minerals in the ocean, right? So different kinds of resources that we can extract from the bottom of the ocean. You know any other branches of science? Can you think of any other ones?
No, I don't. No, I don't know any branch.
Yeah, there are so many. There are so many that it's sometimes overwhelming to think about all of them. We'll look at a few other ones. Okay, so a few other ones might include, if I can think of just some examples, the study of people, right? Just the way people live and act and behave is anthropology. The study of human culture is sociology. The study of, say, the way the environment works, right? And how all like animals and plants live together in the environment. That's ecology. The study of how money works is economics. The study of, let's think of a really random one. The study of fish is ichthyology. Right? You can study pretty much anything, and there's gonna be a science for just about everything. That's the point. So we have some people listed here who have problems to solve. Which branch of science could help them? Let's look at number 1 here. A doctor finds that there is a new type of virus. Uh-oh, that sounds very familiar. What branch of science can help this doctor?
I remember this doctor is in China.
Yeah, there are. Yeah, there are. That's all over the news right now, right? But there's a certain kind of branch of science that looks at, well, there are actually many branches of science that could help this doctor. If this doctor wants help with this new type of virus, there's a branch of science we already talked about that could help him. What would that be? Let's see if I can. We could say biology, right? It's a study of living things. In particular, there's a branch of biology simply called medicine. Right? Medicine's a science. Study of how medicine works and how to heal people. Right? There is a kind of medicine called epidemiology, which is the study of how disease works. So if this scientist wants help Or what if this doctor wants help and he wants to look at somebody who specializes in disease? He can find an epidemiologist. And even more specifically, if he wants a scientist that only focuses on viruses, well, we call that virology. Right? These are all different kinds of science that could help this person. Okay. Any questions there?
No.
Okay. Look at number 2. A mechanic needs a strong glue to stick two materials together.
Physics.
Good. Something like physics. A physicist. Physics. Any other ideas? Specifically about chemicals, like materials, you probably want to look for a chemist, somebody who studies chemistry. And then there could be a specific kind of chemist or a specific branch of chemistry called material science, right? And that's looking for specific kinds of things that we can make, right? It's the chemistry basically of making things, like a new kind of glue or something. Number 3, an architect must design a building that is cool and quiet inside. He wants to build something. What kind of science would help him? Again, maybe physics, right? Physics deals with things like how does heat move, or how do things get cold, right? Again, maybe chemistry, and again, maybe material science. But specifically for building things, right? The specific kind of scientist that we want, especially when we're building things, is an engineer. Engineers are the scientists that specialize in building stuff. Okay, good. Alrighty. Any questions there?
No.
So who is a scientist? Well, you can be a scientist too. Let's look at this person. He's a scientist. And we'll watch a little video about him. Can you read this for me?
Wait. After close family friends died of the cancer, 15 years old Jack Adraka began working on the way to help future patients. When Jack was 17, he was a 2014 National Geographic Emerging Explorer who studies cancer diagnostic. He developed a promising test to detect early signs of cancer.
Good. Okay, any words there you don't know?
I don't know the diagnostics.
Good. So diagnostics are the things that doctors use to find out what disease a person has. Okay, so diagnostics are like signs, right, that a person has a certain disease. So if somebody has like a tooth disease, right, some diagnostics of the tooth disease might be that their tooth hurts, maybe the area around the tooth is swollen, maybe the tooth feels loose, or maybe it has a weird color, right? Those are all diagnostics of a tooth disease. Does that make sense?
Okay.
Yeah? Okay. Good. So we're going to learn about this person, Jack. Jack was 15 years old when he had a close family friend die of cancer. Right? And then when he was 17, he started to become a scientist. He was named a National Geographic Emerging Explorer. And he focused on cancer diagnostics. Okay, let's watch a little video about him.
Okay.
Local job, perhaps teaching kids these.
Can you hear the audio?
Yes.
Okay.
I can hear, but it's lag. It's a little bit of lag.
Sorry. Let me pause this. Did you say it's too loud?
Yes.
Okay, let me see if I can turn down the video.
But but in video there's a bit of laggy.
A bit of lag?
Yes.
Yeah. Yeah, I can't really help with the lag. It's just delay. The internet has just been really slow recently. Is this better?
It's still lag.
Still loud.
Still lag. Still
Lag?
Yes.
Okay, well, the lag we can't help, but the loud, is the volume too loud or too low?
That's okay.
It's okay. Okay. Yeah, I can't help with the lag.
I wake up at about 5 a.m. to get ready for school, and I go through all my classes, and it missed, of course. That's electromagnetic, so then I catch the MARC train down to Georgetown. I'm a 17-year-old high school student, and I'm also a cancer researcher who focuses on cancer diagnostics. 85% of all pancreatic cancers are diagnosed late. I was inspired by the death of a close family friend. They passed away from pancreatic cancer. They went from a perfectly healthy-looking human being into pretty much a living skeleton in 6 months. It was just a horrifying experience to watch, and I wanted to make sure that no one else had to go through that pain and suffering again. Armed with 8th grade biology, I set out to change cancer diagnostics. I didn't know anything about being alive. Yeah, I would blow my cells up in the centrifuge or overheat them. It was terrible. But in science, failing is like one of the best things that you can do. The breakthrough moment of this entire test, that was one of the happiest moments of that entire journey. It's like a diabetic test strip, and you just take a single drop of blood or urine or whatever you're trying to detect the protein in, and you can instantly see whether or not you have the cancers. finding out that my test strip did work, that brought to me to mind that, hey, maybe I could help save someone's life. My major goal is to save as many lives as possible and prevent the pain that comes from like pancreatic cancer as well as other cancers. Hey, Mom.
Okay, so there we have that story of that young guy. He's only 17 and he's researching cancer, and he develops a test to kind of detect early signs of cancer. So it kind of shows that really anybody could become a scientist. Okay, so to discover the world, let's just say discover the world, scientists will first make observations, right? So they'll notice something that they see and they want to find out more about it. And then they'll try to explain what they see by first developing theories. What is a theory?
Theories are...
Have you seen this word before?
No, I didn't see.
Okay, so theories are why people think something happens. They're just ideas that explain why. So it explains, theories explain observations. What's an observation?
I don't know what to.
Observation is simply something that you see. Okay, so for example, you might see that when the weather gets wet and humid, right, which it often does in Hanoi, mold tends to get on everything, right? Do you know mold?
What, mold?
Yeah, mold.
I don't know.
Mold. If I can. So let me summarize. Excuse me. Let me summarize this. Observation is just something we see. Right? A theory is just an idea that explains an observation. And for the last bit of this, we test theories to prove if they are right or wrong by doing experiments. Okay, so does that make sense?
Yeah.
Yeah, good. So an example would be your observation. Erase. Let's say your observation is that when the weather is humid and wet, mold gets everywhere. And this is especially true for Hanoi. When the weather is humid and wet, mold gets everywhere, all over everything. Do you know this word, mold?
Mold is sometimes after that.
Sorry?
After that, there's wet in the house.
Yeah. So in your house, right, around Tet and after Tet, when it's raining every day and it's really wet outside, you'll see like up in the corner of the wall or something, there's like a little black thing that appears, right? And it smells bad. You know it?
Yes.
It's kind of like a plant, but it's not really a plant. That's what we call mold. Okay, so you observe, you see that when the weather is wet like that, mold starts to appear all over everything, every building. Your theory might be, well, what's your explanation for this? Why does this happen? Why do you think that happens?
It's wet and mold.
Why does mold, can you tell me, why does mold come when the weather is wet?
Because when the weather is wet, there is going to that sometimes it's in our house too, and if we not brush it early, it will get mold.
Okay, good. So our theory might be that right? Simply wet weather allows mold to live in the house or all over everything, right?
Yeah.
Now, how do we test that to prove if it's right or wrong? Theories sometimes are correct, sometimes they're wrong though, right? People used to think that, for example, that the sun moved the earth, right? For example, used to think that the sun moved around the earth or that the earth was flat, right? Have you heard that before?
Yes.
Yeah, nowadays we know that that's not true, but those were theories that were wrong and they were proven wrong using experiments. Okay, so our experiment to prove if your theory is right or wrong might be that, well, we'd want to say, leave one room wet, leave one room dry, then see which room gets mold, right? We have one room that's wet, one room that's dry. See which room gets mold, right? And that might help us to prove your theory. Does that make sense?
Yes.
Okay, that's kind of just how science works. It's the basics of science. We make an observation, then we make a theory, and then we do experiments on the theory. And what do we do if the theory is wrong? Well, we fix it, right? We change the theory so that it might be right. We use our results from the experiments to learn and make new ideas. Okay, so let's look at an example one. Another example here. Your observation is that the plants will die without several hours of light every day. Theory is that plants need light to grow well. Now let's look at these experiments. Which experiment do you think is better to test this theory? So experiment A, we have two plants. We put one outside in the sunlight and one in a dark box. And we give the one outside water, but the one inside no water. And then experiment B. It's the same thing, except we give both plants water. Which experiment is better to test the theory that plants need light?
I think the experiment A.
So experiment A, look at the problem here. Right, we expect in both experiments that we're trying to see that plants need light to grow well, right? And we assume that the plant that we put in the box will not grow well because it doesn't have light. But if we don't give that plant water, right, we don't know what's causing it to die. Is it the lack of water or the lack of light? If we keep everything the same for both sides though, except for the light, we know that the reason the plant dies is because of the lack of light. Okay, does that make sense? So in that case, experiment B is the better experiment because the only thing that's different between the two plants is light. In experiment A, there are too many differences, so we cannot prove that plants need light. Only B can prove that. Okay, so let's look at some things under a microscope. Okay, so this, what is a microscope?
Sometimes I use it.
Okay, what do you use a microscope for?
We use it to discover very small things.
Yeah, discover really, really small things, right? A microscope shows us things that we could not possibly see normally. And scientists use microscopes in a lot of experiments, right? It's a pretty useful tool. It helps us to observe many things, helps us to see things. Let's look at these. This is something from a microscope. Okay. Any idea what it is?
I think it's a virus.
Could be, right? And you're really, really close, actually. In fact, every person has these in their body. These are really, really important things. These are called blood cells. Right? Have you seen this word before? A cell?
Cells, yes.
What's a cell?
Cells mean part.
Yep, it's the smallest part of your body. Right? It's the smallest part that makes up a living thing. It's like the building block of living things. Some living things only have one cell, like a bacteria. Right? Some things have trillions of cells, like people or animals, right? These cells right here are the cells in your blood. There are many kinds of cells in your body, but these particular ones are blood cells.
But what is the big thing in that picture?
My guess is it's a white blood cell. There are two kinds of blood cells. Red blood cells, which are these little ones, right? Red blood cells carry oxygen in your body. It carries, when you breathe in air, in your lungs, it takes the oxygen out of the air, and these little cells carry the oxygen to your body parts, which helps you to live. My guess is this is a white blood cell. So these are red blood cells, these little ones. The big ones are white blood cells, and white blood cells are the are the cells in your body that fight disease and infection. So when you get sick, your white blood cells are going to help you to feel better. Does that make sense? We'll study that.
Biology.
Very good. Exactly. That's biology. And in particular, that's a certain kind of biology called microbiology. Just like microscope shows us small things, microbiology is the science or the science of tiny life, really. That's what it means. It's the science of all things living that happen on the microscopic. Okay, good. Can you guess what this is?
I don't know.
This one's a tough one. This is graphite.
Pencil is pen.
Yeah, it's the tip of, it's called graphite. What it looks like if you zoom in, and then if you zoom in even more, it looks like that. What studies this? Think about materials, elements, chemicals. What do you study this in? What kind of science?
Physics.
Could be physics, but more likely this one's going to be chemistry, right? Because graphite is a kind of chemical, right? A material. So we have graphite here. Good. Look at these. Can you guess? What do you think this is? Long things.
Hair. That is hair.
Very good. These are hairs. So if you zoom in a little bit, right, hairs, an individual hair looks like this. And if you zoom in even more, they look like that on the inside. Good. All right, time to make questions. We will find the answers during the course. So that's about all the time that we have for today. Okay. So, Fat, do you have any questions about anything at this time?
No.
Okay. So, good talk today, buddy. It was nice to talk to you. Okay. Have a good day.
Yeah.
Bye, Fat.
Bye.
Okay, thank you. Bye bye, teacher.
Bye.
Hello, Fat again. Hello.
I hear.
Okay. So, do you understand the lesson today?
Yes, I understand.
Yes. All of this or almost.
Thầy ở đâu như nào?
Can you tell us? Can you tell it again?
Do you understand the lesson today? All of the lesson or just a little bit or almost the lesson?
Almost.
Almost the lesson. It's really good. And you were really excellent during the lesson today that you have questioned your teacher and answer almost the question of him. So we will see you soon on another lesson, okay? Okay, so thank you for today. Okay, thank you, Fat. Goodbye. Goodbye.